Alright, science enthusiasts, today I'm diving into one of the most powerful and terrifying inventions of the 20th century, the nuclear bomb. Buckle up because we're about to explore the explosive science behind the ultimate weapon. So, what is a nuclear bomb? Well, it comes in two main types, atomic bombs and hydrogen bombs. Atomic bombs, like the ones dropped on Hiroshima and Nagasaki, use nuclear fission. Hydrogen bombs or thermonuclear bombs use nuclear fusion and are even more powerful. Let's break down the basic physics. At the heart of a nuclear bomb lies the concept of nuclear fission or fusion. In nuclear fission, the nucleus of an atom, like uranium-235 or plutonium-239, splits into smaller parts. This splitting releases a massive amount of energy, thanks to Einstein's famous equation E=mc2. Essentially, a small amount of mass gets converted into a huge amount of energy. A critical part of this process is the chain reaction. For a bomb to explode, it needs to reach a critical mass of fissile material, creating a self-sustaining reaction that unleashes all its destructive power. Now let's talk about the components of a nuclear bomb. First up, the fissile material, typically uranium-235 or plutonium-239. These materials are surrounded by conventional explosives that compress the fissile core, triggering the chain reaction. You'll also find neutron reflectors, initiators, and a tamper to enhance the reaction. There are different types of nuclear bombs too. The gun-type bomb, like the one used in Hiroshima, fires one piece of fissile material into another to reach critical mass. The implosion-type bomb used in Nagasaki uses explosives to compress the fissile core. And then, there are hydrogen bombs, which use a fission bomb to ignite nuclear fusion, creating a much larger explosion. Making a nuclear bomb is, thankfully, incredibly complex and highly regulated. It starts with the enrichment of fissile material and involves assembling a core and a precise trigger mechanism. Strict safety and security protocols are always in place to prevent accidents and unauthorized use. The detonation sequence is intense. First, the conventional explosives are triggered, compressing the fissile material. This initiates the chain reaction, releasing an enormous amount of energy in the form of a massive explosion, intense heat, and deadly radiation. The aftermath of a nuclear blast is devastating. There's an immediate shockwave and fireball, followed by harmful radiation and fallout. The long-term environmental and health effects are severe, causing lasting damage to both the planet and human health. Historically, the use of nuclear bombs in Hiroshima and Nagasaki changed the world forever. The Cold War era saw numerous nuclear tests and an arms race that brought humanity to the brink of destruction. Today, modern concerns revolve around non-proliferation and global disarmament efforts to prevent such catastrophic events from happening again. So there you have it, the explosive science behind nuclear bombs. It's a sobering reminder of the power we wield and the responsibility we carry to use it wisely. Thanks for watching and stay curious.